Hi, and welcome to this short video on Curiosity's high-performance enterprise data masking. In the next 5 minutes or so, we're going to cover 4 things. First, how deep scanning of your data enables high-quality masking. Second, where masking fits in the wider test data provisioning lifecycle. Third, some of the typical problems teams hit with homegrown and legacy masking solutions. And finally, a quick example. When we install the Curiosity platform, the first big activity is gathering up information about the customer's data landscape, building a centralized data catalog of everything that exists within it. There are multiple ways to do this. We can use our scanning capabilities driven by AI agents, or we can integrate through the Curiosity MCP server. Either way, we can build the catalog from the necessary data sources within an organization, such as databases, Swagger specs, messages such as JSON and XML, and much more. From there, we can start to build the relationships between those different data structures. This is critical if we want to mask in a federated way, consistently across systems and teams. Scanning does 2 more important jobs at this stage. It identifies data quality issues before they contaminate downstream environments, and it identifies PII and sensitive columns that need to be masked. That catalog then combines with our other technologies to provision the right test data to the teams requesting it. Masking is often seen as one of the most technologically straightforward ways to provide test data. It uses obfuscation and anonymization to remove sensitive information from production data before it's moved into lower environments. That gives you 2 things at once. Compliance. If the data ever leaves an environment, you remain compliant with data privacy regulations. Realism. The data keeps the production-like qualities that development and QA actually need. Again, in practice, the flow usually looks like this. You take a copy of production, typically via a data refresh, into a stage environment. From there, you either mask in place or in flight, and provision the masked data to your dev and QA environments. We won't cover it in this session, but this is very often combined with subsetting as well, masking a right-sized slice of production rather than the whole thing. Now, let me show you one of the activities we've been working on for high-performance masking. This example deterministically masks values in SAP, BSEG and BKPF tables stored in a SQL server. First of all, I'd like to take a look at the definition which has been scanned using our deep scanning techniques. Here we can see the 2 tables that we are interested in, BKPF and BSEG, and we can see that they have been tagged as having sensitive data in them. If I look into our BKPF table, we can see that it has detected username and BKTXT as 2 of the columns. If we look at the BSEG table, we can see that there's lots of columns which have been marked as having non-sensitive data in them. One of note is for the SGTXT column, which has been marked as having PII data in there. If we go to our activity and look at the masking rule set, we can see that those tags have actually come through to our masking rule set, and therefore this makes it a lot easier to actually identify which columns need to be masked. Now, for this example, I have decided to mask the bookers column, even though it is marked as non-sensitive information. This is purely for demonstration purposes and to show the consistency of our deterministic masking. If I go and look at our BKPF and BSEG tables, you can see for the bookers column that we are using the same deterministic function to mask, and that will mean that the same input is always masked to the same output value. So the join between the BKPF and BSEG still holds our masking. Referential integrity is preserved. Now we won't be showing it in this example, but the deterministic rules can be used across all your different data sources. That means if I go and use this function across our different data sources, they will be masked in the same way, and that way we can achieve a federated mask across all your different data sources. Now if I go back to my data activity, if I go and look at the log of one of the times that this job has been masked in the parent job 28099, which gives me to the child job of 28100, as you can see, we're processing 30,000 rows per second. At this rate, masking datasets in the billions becomes a practical everyday operation rather than a weekend-long job. If I go back to my data activity, we also have the ability to create audit jobs by executing and asking it to create the audit reports here. If I go and look at some examples of these, we can see here that we can actually prove the deterministic masking. If I look at my BKPF table, we can see that the company code C796 is masked to C210, and we can see that it's consistently happening in our BSEG table, showing off our deterministic masking capabilities. Audit trails like this are essential for both internal confidence and for demonstrating compliance. I'm just going to quickly go over some of the typical problems with masking technology. Homegrown solutions need constant upkeep. This is especially true in the AI era. It's easy to spin up a masking script, however maintaining them and guaranteeing they behave consistently is a problem. Consistency across teams. If different teams use different tools, it's very difficult to mask data deterministically, i.e. consistently across your whole landscape. You need the same masking algorithms available across your entire tech stack. Legacy masking is typically very slow at large volumes. When you're masking datasets in the realms of billions of rows, you need modern high throughput technology. Data quality. A masking project can become a data quality project. Once you find bad or missing data, you need to decide what to do with it when you mask it. Do you just pass the bad data through or blank it out? You need to decide before you mask. So let's talk about the key features of what we have within the Curiosity software. We have very high performance masking routines which can process data in parallel and automatically partition masking for very large tables. We have a massive array of masking algorithms which can be extended using custom functions. Crucially, our masking can be done in a deterministic way, meaning that it can be used for federated masking across your entire data landscape. We have encrypted audit trails to show what masking has happened. We offer wide support for consistent masking from mainframe to file to databases to ERPs. The same technology can be used to age and enhance your data. It's very easy to go from deep scanning to map masking functions. We handle tables with no primary keys. We can also perform in-flight or static masking depending on your choice. We also have an integrated set of utilities that link together so you can subset, clone and mask in one go. We create an ecosystem to help you build much more nimble data provisioning processes. Thank you very much for listening to this short video. If you have any questions, please reach out to myself or another Curiosity representative.